Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. In the previous video you have seen how the knowledge of formulas of the surface area of solids helps you in cracking the problems of mensuration. And now in this video I am going to take up the volume of solid shapes. The solid shapes which I am taking up I'll restrict myself to cube, cuboid and cylinder as of now. And if you know these basic shapes, obviously this knowledge will go a long way in deciding your success in other solid shapes like you have the cone, you have the sphere, hemisphere, the frustum and the hollow shapes also. Okay, so watch the entire video, and before taking up the questions based on volumes of solid shapes, let me tell you about the nominal costing super combo of quant and reasoning which we have brought out very recently. And this quant and reasoning combo has helped hundreds and thousands of students to qualify the school olympiads, the entrance exams like RIMC, and even placement exams. So many people got placed by studying from our quant and reasoning course. The quant course is basically a ebook of short tricks, and it gives you 350 short tricks of 24 different topics of quant. 24 different topics means I think everything in quant is covered through short tricks: mixtures and alligations, pipes and cisterns, speed problems, age problems. You have short tricks for everything, and that's what we have given here. So we have given the video support directory also, both in the reasoning course and in the short tricks. This is fully solved and develops 10 times faster speed of calculating. People who have studied from our quant course, they see the question and tell the answer, and I'm not boasting about it. If you want to have a glimpse of it, the method to get the copy is mentioned here. You can send me a message on WhatsApp. 9896369963 is my number. And even our reasoning course, 18 different topics covered, and all the concepts, illustrations, practice questions, previous year questions are mentioned in the course. So get a copy now for availing this nominal costing ebook and ebook of quant and reasoning. Let's see some questions in hand now. The first question: if each edge of a cube is reduced to half. Now he is asking us to take the edge as A. So what happens to the side? A becomes reduced to half. That means A upon 2. So the side of the cube is getting reduced by half. We need to find the new volume. So what happens to the volume when the side is reduced by half? Does the volume also get reduced by half? We'll just check in a minute. If you see the original volume is A cube, right? What is the formula for finding the volume of a cube? Side into side into side, that is side cube or A cube. Now the new volume here will be the cube of A upon 2, because the side has been reduced to A upon 2. And so this is not A cube upon 2. This is A cube upon 2 cube, which is 8. And therefore you can write this as 1/8 of A cube. And what does it mean? 1/8 of, what is A cube? A cube is the original volume. And therefore the answer for the question is that the new volume will be equal to 1/8 of the original volume, right? Next, so a very easy question here. The edge of a cube or the side of a cube represented by small a is given 7 2/3 meters, which is 23 by 3 meters, and we need to find the volume, and then we need to express it in terms of liters. So there is a conversion factor which is being used in the question. The volume of a cube is side cube, and the side is 23 upon 3. So we need to find the cube of 23 and the cube of 3, which is 27 obviously in the denominator, and the cube of 23 happens to be 12167. 12167. And if you perform this division, you will get your answer in decimals. It is 450.6296. Now the unit of this is going to be meter cube because the side was in meters. Now this is the answer for the first part. Find the volume. The volume is this. How do you convert meter cube to liters? For that you should know that 1 meter cube is actually equal to 1000 liters, and therefore 450.6296 meter cube will be this multiplied by 1000. So if you multiply this by 1000, the decimal will shift 3 digits towards the right. So it will be 450,629.6 liters, and that is the conversion which we have to make in the question to convert meter cube to liters, right? Next, here we have a compound figure where we have combined two cylinders. As you can see, the common portion, this portion, is of the same radius. Right? We have combined it end to end like this. So the radius here and the radius here has to be same. And the diameter here is given as 7 centimeters, and so the radius is 7 by 2 centimeters. There's a reason why I write 7 by 2 and not 3.5, because decimals are a little bit difficult to handle as compared to fractions, and there might be a chance that some of the terms in the numerator and denominator will get cancelled. That is why I prefer to use fractions. Now this is actually the cylinder which was vertical is now horizontal, right? So this is the height h1, which is 14, and this is the height of the other cylinder h2, which is 17. And now using this data, let's find the volume of this figure. Whenever there is a compound figure, that means a combination of two or more figures, then you just add the volumes of the individual shapes. So how do you find the volume of this figure? It is pi r square h1, which is the volume of the cylinder on the left, plus pi r square h2, which is the volume of the cylinder on the right. And now why did I use h1 and h2? Because the heights are different. And why did I use r in both of them? Because the radius is same. And now I'll take pi r square out, and I'll have h1 plus h2 left in the bracket. So I can put the values 22 upon 7. R, what is r? 7 by 2, right? So 7 by 2 times 7 by 2, because it is square, times h1 plus h2 is 14 plus 17, that is 31. So I'll put 31 here. So 7 cancels 7, 2 cancels this 11 times. 11 times 7 is 77, and times 31, and divide that by 2, you will get your answer for the question. So I can leave that as a DIY for you. You can tell me, if you multiply these two and take half of that, that means divide it by 2, what answer will you get in centimeter cubes? So this is a DIY calculation for you. You can post your comments in the comment box here. Let's see the final question for this video. The length of each edge of a cube is increased 4 times. So A, which was the original length of the side, is becoming 4A now. 4 times. So what is the question? What will be the percentage change in the volume? Wow. Percentage change in any dimension. Very important concept for school exams and also for quant exams. Percentage change. See what happens to the volume. Originally, when the side was A, the volume was A cube, right? And now the volume changes to 4A cube. Don't write it as 4A cube. It is 4A in the bracket and then cube. 4A times 4A times 4A, which is 64A cube. Now this is the new volume, And whenever we have to find the percentage change in anything, just see how much change is there, divide it by the original quantity and multiply it by 100. Now this is the general formula for finding the percentage change in any quantity. So what is the change? Originally it was a cube, the volume was a cube, and now it is 64 a cube. So when you take the difference of 64 a cube and a cube, you get 63 a cube divided by the original was a cube, right, and times 100. So pretty easy, a cube gets cancelled and you have 63 times 100, which is 6300% increase in volume, and that completes our question. Friends, not difficult, but you should know this concept very thoroughly. So friends, if you are enjoying all these videos which I have been posting on the channel, do share it with your friends, do subscribe the channel and click the bell shaped icon for getting all the notifications on your mobile. Thanks for watching this video and all the best.